All right. Good afternoon, everybody. Welcome to GeoStrata Extra. My name is Mike McGuire. I am hosting what's going to be a wonderful conversation this afternoon. Those of you who are familiar with the GeoStrata Extra interviews, this is going to be another wonderful installation. Those of you who are unfamiliar with this, I hope you are familiar with GeoStrata magazine. So GeoStrata magazine is a magazine that comes out 6 times per year. It is the magazine for the Geo-Institute of ASCE. And what is the Geo-Institute? The Geo-Institute is an institute of ASCE with about 12,000 members representing primarily geotechnical engineers and geologists. It's a wonderful, active institute, both at a local, regional, and national level. And GeoStrata magazine is the magazine where geotechnical engineers, geologists get to describe really great things in a format that's a little less formal than a journal and a conference paper, but still has a lot of nice technical meat. In addition to technical stories, there are op-eds, commentaries, information about upcoming events, profiles of members doing really cool things, spotlights on students, stories about people who have done great things in our field. So please check out GeoStrata magazine. Hopefully that is coming to your inbox every other month. You can see it online. If you're not getting the magazine, you can go to your ASCE membership profile, make sure that box is checked to be a member of GeoStrata. So today we are going to focus on an article that appeared in the most recent issue of GeoStrata magazine. This is an issue in the June-July of this year. It is featuring accelerated construction and foundation reuse. And I am joined today by Dr. Archie Filshill, Dr. Teresa Loux, and Dr. Majid Khabbazian. And they wrote an excellent article on opening I-95 in an astonishing 12 days after a catastrophic accident and subsequent bridge collapse. So this article, it does a great job of capturing the overview of the events, the unfolding of how this problem was addressed and solved in using a very innovative solution, which we'll talk about today. Just a little bit more about our esteemed authors this afternoon. So Dr. Loux is the Chief Technology Officer at Aero Aggregates North America. It is headquartered in Eddystone, Pennsylvania, just south of Philadelphia. Dr. Majid Khabbazian is a senior engineer of the Chadds Ford branch of Schnabel Engineering. And Dr. Archie Filshill is the Chief Executive Officer of Aero Aggregates North America. So welcome to you all.
Thanks, Mike.
Thanks. All right, great. So we've got a number of questions that we're going to kind of use to kind of steer our conversation today. There's also going to be an opportunity for our audience members to write questions into the chat, and we will do our best to address those questions during our conversation. Our conversation will run about an hour this afternoon, maybe a little shorter, maybe a little longer. We'll see how it goes. So I'd like to start with a question kind of to each of you individually, just to kind of get us warmed up here. So first question is for you, Majid. Prior to this project, had you collaborated with Archie and Teresa in any way, or professionally, or perhaps through the Delaware Valley Geo-Institute?
Yes. Well, first of all, thank you for having me. I believe I've known Teresa and Archie for like over 10 years, I believe. I'm not quite sure when where I met them first. If I want to guess, it was at DVGI. But Archie, Teresa, if you have a better memory, please jump in.
I remember you doing a lot of work for DVGI on the attendance sheets and helping with that. So that's where I first remember.
Okay, so then, yeah, that's pretty much about 10 years ago, yes. And yes, we've had a few projects that we've worked together. Obviously, the last one was this I-95, and right before that, there was another project, a temporary ramp at JFK Airport, which just happened to be a temporary MSC wall with foam glass aggregate, very similar to what we use for this project.
Excellent. Excellent. And so for the audience, the Delaware Valley Geo-Institute is definitely the best chapter of the Geo-Institute out there. And it is currently chaired by Teresa. So very active throughout the year, many dinner meetings. There's a wonderful student night that DVGI runs where students get a chance to showcase their research and present their work and also their scholarship opportunity. So the DVGI is an example of really how the Geo-Institute can function best at a regional level. So that's, appreciate your efforts, Teresa. And Archie's also a past chair as well, right? A few years ago.
Correct.
Yeah.
Yep.
So Teresa, we're going to be talking a lot about foam glass aggregate this afternoon. And I hope a lot of the audience at this point is aware of what that is. And if they've read the article, they've got a sense. But can you make sure we're all on the same page and just kind of give us some of the highlights of this material?
Yeah, absolutely. I can give some background. So foam glass aggregate is a type of lightweight fill. And as many of folks on this webinar will probably know, right? Lightweight fill is typically considered a type of ground improvement, although it kind of works in the opposite way that many traditional ground improvement options work, right? So instead of improving the characteristics of the soil, right, and increasing the capacity of the ground, right, using a lightweight fill, we're just reducing the demand on that subsurface below. And so lightweight fills in general, they're utilized and considered in the design process by geotechnical engineers mostly when they're dealing with issues like raising elevations over soft soils or existing infrastructure. So it might be that you have in place utilities, maybe a tunnel or culvert, or maybe you have piles or other types of structures in the ground that you're trying to minimize load or weight on. You might also be trying to reduce lateral pressures on, say, a retaining wall or some other type of vertical structure. Many of the projects that utilize lightweight fills are driven by resiliency concerns, right? The raising grade issue over, again, either soft soil or existing infrastructure. Another unique aspect of most types of lightweight fills as well is that they are generally good insulators. So frequently you'll see lightweight fills used in building construction just to be an insulation material. You can also use them on infrastructure projects if you're trying to protect the ground from freezing. We don't have that very much in the mid-Atlantic, but certainly other parts of the country and in the world, that might be an issue. And so what distinguishes foam glass from the other types of lightweight fills that are out there? And I'll just give you a couple attributes. The first thing is that foam glass aggregate is the lightest of the lightweight aggregates out there. So as manufactured, the product comes out at a bulk unit weight or bulk density of about 15 pounds per cubic foot or less. And once you place it and it has some moisture on it, you're going to be somewhere between 20 and 25 pounds per cubic foot in place. So it's really light. And because it's so light, sometimes it's referred to as an ultra lightweight material. Another unique thing about foam glass is how it gets placed, right? How it gets delivered and placed. So again, because it's lightweight, we can get up to about 100 cubic yards in a single truckload that gets delivered to project sites. And then once it gets there, it gets spread out in about 2-foot lifts and then typically just tracked over with either a dozer or an excavator in order to seat the material. The equipment will take 4 passes over top of that lift, and then the next lift can be placed, right, the next 2 feet. So construction using foam glass aggregate, it can happen very, very quickly because of that. And another benefit is that there's no issue with trying to have an optimum moisture content for compaction, right? It's a very coarse aggregate, and so there's no optimum moisture. And then kind of lastly, right, I would say that foam glass aggregate is very unique in its composition. It is made from primarily recycled glass, and that's container glass that gets collected through curbside recycling programs primarily. And so because of this, soda lime glass composition, it's, that helps certainly on the sustainability side of things, but it also helps in just the fact that it's generally non-reactive to chemicals or other types of harsh environments. So hopefully I hit on a couple key aspects there.
No, that's great. So folks that are on the East Coast, if you find yourself going down 95, you will pass pretty close to the aggregates plant. I'm going to invite everybody to look at your plant. But it's a really cool operation. And one of the things that I didn't believe until I saw it was that when you manufacture it, there's no like post-processing to get it down to its final size. That it's all done by the cooling process. So it comes out of this kiln very, very hot. And because it's glass, it cools really rapidly. And then you get this thermal fracturing. And it's a magical thing. And it fractures you end up in chunks that are about the size of a tennis ball, thereabouts. And so there's no crushing of the material done at the plant, which is pretty cool.
Yeah, we have a lot of contractors that get very disappointed, Mike, when they come through the tour and want to see our crushing and screening operation and realize there is none.
Yeah, it's neat. And it makes a neat sound as it happens as well. So, okay, so it's not every day that us, as civil engineers, that we get a new material to play with. And I'm thinking of geosynthetics in the 70s and 80s, and when I first learned about this foam glass aggregate, I was like, wow, this is really cool. It's like a new material. And I imagine you all had this similar kind of experience at some point. So Archie, I wanted to kind of get a summary from you of at some point you learned about this material and you decided to act on an idea to create a company and are scaling this company. So could you kind of share a little bit of this storyline?
Yeah, sure. So prior to Aero, I had a construction company, and we did a lot of design build work. We did MSE walls, lining systems, and we did lightweight fill. And what we saw was the need more and more for lightweight fill, right? What a lot of geotechnical engineers see now. We're building in areas that we never would have built in before, right? Because land's scarce. And we had opened an office in Ireland and one in Turkey, and we had teams working around the world. And it was during a meeting in the UK with the whole team talking about options for lightweight fill and talking about styrofoam and talking about pluses and minuses. And it was during that meeting, one of our colleagues from Norway said, hey, why don't you just use foam glass aggregate? And I kind of looked at him sideways and said, what the heck is foam glass aggregate? I've never heard of this. And I like to think I was a new materials type of guy. So started researching it very slowly, but the more I researched it, the more interesting it became. And the tough part was there was just not a lot of written papers on it in Europe. They'd been using it for several decades, but not writing about it. Very much infrastructure type applications. So the more I looked at it, the more interesting it got. And you kind of touched on it earlier there, Mike. I started my career in geosynthetics. And right or wrong, learning the trials and tribulations of getting new materials approved, especially at a state DOT level, right? Not the easiest task, more especially when there's not an existing specification for that material. So that was probably one of the biggest challenges in the very beginning. Okay, this is a very neat material, but there's no guidelines, there's no specifications. And we kind of decided that let's approach the DOT market first, because that's going to take the longest. So let's try and inform them. But I can tell you the geosynthetic experience really helped, because we spent maybe 3 years prior to approaching the DOTs doing a lot of testing, a lot of research, and making sure we had the answers to the questions that we knew were going to come. We didn't want to go, oh, that's a great question, let us get back to you. So I would tell you a lot of preparation to reach out to consultants and the DOTs was a big part. The second part, I'll be honest, and I can use the Geo-Institute as a great example, a lot of support from the geotechnical community, right? Going to the DVGI meetings, there's a lot of great relationships. So spent a lot of time in the beginning vetting it out with, okay, meeting with, I'll leave the names out, but meeting with somebody or a professor and saying, tell me what you don't like about the material, right? If you're going to use this, what's your biggest question? What's concerning you? And because I'm sitting across, don't just say it to make me feel good. I don't want good stuff. I want bad stuff. And that really identified the series of testing that we needed to do. So from a entrepreneurial startup point, once we knew the material was pretty solid, it had the track record in Europe, vetted out by the Swedish Geotechnical Institute, the Norwegian Geotechnical Institute. That was kind of the, okay, we know we have something that's good here. The challenge is going to be how fast can we drive the adaptation in the US.
That's awesome. Yeah, it's an example that I talk about foam glass quite a bit in my classes, and it's a nice opportunity to talk about entrepreneurship in civil engineering. And you all have been so gracious in coming up and actually meeting with students and giving talks. So it's a neat part of the community that is the Geo-Institute. All right, so let's start to get into this fantastic story. And I say fantastic, this story does have a very tragic start to it, right? This involved a fatal truck crash. And so I do want to acknowledge that. And so as we talk about this, we are going to be, there's a lot of really cool engineering, and that's what we're going to be focusing on today. And so we are going to sound enthusiastic about it, but in no way diminishing the kind of tragic start to this. We have all driven on I-95, and I-95 is like a cultural fixture of the East Coast. And we do, I imagine, have many folks with us today who have driven 95, and there's also a bunch of folks who probably haven't driven on 95. So I want to just toss the question up to the three of you. Can you kind of give the audience a little bit of a sense of what I-95 is?
Yeah, I'll take a shot at this one. So right, as many of you know, 95 goes from Maine all the way down to Florida, right? And in some spots it's only 2 lanes of traffic in both directions. In other spots, it might be 4 or 5 lanes of traffic in both directions. And believe it or not, there's only about like 50 miles, I think, of 95 that actually exists in southeastern Pennsylvania, right? So it connects to New Jersey, kind of close to Trenton, and then to the south, it goes into Delaware, just north of Wilmington. And so, kind of in the greater Philadelphia area, it is a major corridor, for commuters, for commerce, right? There's a lot of trucks that travel up and down this route, for visitors, right, to the area, and just people passing through. So, specifically the section where this accident happened, I think the number is something like 160,000 vehicles per day is what this section of 95 sees. So obviously it's very significant. At the time of the collapse, there were 4 lanes of traffic in both directions in this specific section.
Yeah, no, it's a if you grew up along 95, it's definitely not something that is in the back of your mind. It's how you get to and from a lot of places.
And Mike, to put
yeah.
a finer point on that, I grew up 2 exits up, but Teresa and I used that section of 95 to get to Aero every day. So we were also directly impacted.
It's a way to do QA, QC, right? It's just
Yeah.
So I want to know how each of you learned about the event that had happened, the crash and the subsequent bridge collapse, and kind of walk us through sort of how you learned about it, and then eventually you got involved, right? So it went from this thing that you maybe saw on the news, and then the next thing you know, like, oh, I'm in this now. So I just want to kind of get a little bit of that from each of you.
Sure. Well, I'll start, Mike.
Yeah.
I was actually driving up from the Jersey Shore early Sunday morning, and a friend texted me and said a bridge collapsed on 95. And my thought was bridges don't usually just collapse, right? So I called my wife and said, what's going on? She said, no, there's a big fire and the bridge collapsed. And my first thought was, I go up 95, I'll have to figure out how to reroute. And the bridge collapsed around 7:30. And I would say about 45 minutes later, while I was still driving, I get a phone call from the head construction engineer for PennDOT, Howard Windish. So, kind of, wow, this is more than a coincidence that he's calling me on a Sunday morning to say, hey, did you hear what happened? I said, I just heard. And the question was, how much material do you have in inventory? This could be a lightweight fix. Okay, we talk about it. We have enough. About 15 minutes later, I get a call from Harry Lasby at Pannoni, works with the water department. Hey, Arch, we had an accident. We might use lightweight. We're going to need your material. How much do you have? Have the conversation. And then literally about 30 minutes later, the contractor, Rob Buckley, calls and says, hey, Arch, I got to tell you a story. I said, I've gotten the story twice. We have enough material. We're ready to go. So, we were kind of in the loop very quickly on this, like within an hour of the bridge collapse. And I think a lot had to do with all three of those. PennDOT had a fair amount of experience in District 6. Harry did with the water department, and Buckley had used the material on several other projects. So without a doubt, the awareness was probably the biggest thing that we got the calls that quickly.
That's amazing. Yeah. Trish, how about you?
Yeah, so it was a rare Sunday morning that my kids let me sleep in. And so I woke up to the news in a text from my mom, who is an early riser and usually has, the news on TV. So that's how I heard about it. And then, of course, I'm as soon I think the nature, right, of any civil engineers, like you hear about something like that, and then you start to, Google it right there in that moment. So I started, looking into the news myself. And then, I don't know, it was probably pretty early that morning that I got a call from Archie as well. So.
And so, yeah, Majid, at some point, like you got, I guess, a call from Aero, right?
Yeah, so I think like everyone else, at first I heard it in the news sometime, it was like Sunday afternoon. And Monday morning, I think I got email from Archie, it was like 5:30 in the morning. And he said, let's talk in the morning about this I-95 collapse. I was like, okay. So we talk about it. It was like 7:30 or something. We talk about it. And that was the time that I was like, okay, I need to do research. I need to dive in and see what's going on, because Archie was like, are you interested to be part of this? And I just said, yes, of course. So after that, yes, I think Archie sent me a couple of documents, and then I also started Googling that. And I remember, Archie, that Monday morning, you told me, start working on a proposal.
Yes. Yeah, exactly right. And it was, one of the things that we did that we don't normally do, for a bit of a finer point here, we supply foam glass aggregate. That's all we do. But when we arrived and we talked with Buckley, the general contractor, there were so many things going on. We had just had the experience of working with Majid at JFK Airport, similar cross section. We realized it was going to be very similar, welded wire baskets, geogrid, same height. What we said to Buckley was, if you want, we'll take all this on. We'll take the design, all the material supply, the foam glass. And he said, that would be great. I've got 400 other things I have to focus on right now. So the idea was getting the team back together, calling Majid, you know, you're very familiar. You just spent a lot of time doing the design for JFK. We're looking for something almost the exact same, but 95. You know, how fast can you turn this around? Because everything was, you know, design, build, design, right? Start working on it and knowing that the design is going to fit into what you're doing. So I would tell you one of the comfortable things was, as we're starting the work and Majid's working on the design, you know, everybody on the call, knowing what needed to be done for an MSC wall, knowing the details, it was very live, calling in field changes directly on the cell phone. Majid, this is what we're looking at. Does this work for you, right? Teresa, they want to do this. Is this okay? So it was really live process the whole way through.
Yeah, yeah. And to just quickly kind of recap the events that are described in the article. So this truck accident, this truck crash happened. There's an off ramp off of 95, and it makes thank you, Teresa. Yeah, so you see this off ramp, and where Teresa's cursor is moving, there's a kind of a left bend in the road, and a truck carrying gasoline came in too quickly and was not able to make that turn and slammed into the abutment, the bridge abutment on the northbound side. That very intense fire caused that northbound section to collapse, and the southbound section was heavily compromised from the heat. And so now you have this situation where a major artery is out of commission. You know this is going to take some time to rebuild. There's a pretty significant skew to this bridge, and so they're thinking like 3 to 6 months to replace this thing. So this idea of the temporary fix came about. Then the idea that this temporary fix needed to be lightweight was prompted by the fact that underneath this I-95 bridge is Cotman Avenue, where there's several very significant utilities. And the idea that, you know, placing a conventional weight embankment fill there would just compromise those utilities. So as this foam glass embankment solution kind of was coming into focus, I imagine there were a number of constraints and, you know, things that were really important about that design that burbled right to the surface that you knew you had to think about. What were some of those things?
I can start with the first one, and it was timing. Everything needed to be done yesterday. So Majid will tell you, we called and said, you know, work on the proposal. We came back with a proposal and said, you know, about 2 weeks, we'll have all the drawings and everything done. And the response was, that's great, but we need something tomorrow morning before breakfast, literally. And we said, we don't need 60 drawings, though. That was the good news. So eventually we will, but to get started, we need cross sections. And to his credit, he got right on it and, you know, probably worked through the night to get us stuff the next morning so we could get started. So that was definitely priority number one. Everything was speed. How fast can we get 95 open? How fast, how safe can we do it? And that was the general theme for not just Aero and Schnabel, but everybody involved in the site, the demolition contractor, Avenizio, and Buckley, who's doing the rebuild.
Yeah, and that even goes to the materials as well, right? So Archie already mentioned, like, as part of this project, we actually supplied the geogrid and the baskets and all of that, and in addition to the foam glass aggregate. And so, you know, we were talking to folks that were, you know, stealing from another project to be able to supply this one, right? Or just kind of borrowing it and allowing it to be replaced. So, you know, certainly we weren't the only ones doing that. I think, you know, a lot of folks were able to contribute with kind of materials on hand that they were able to lend to, you know, to the efforts. So.
Yeah, that's a good point, Teresa. One of the things that Buckley brought up was, as much as it was a design build, it was a design build with what's available and PennDOT approved. So it was a bit of a four-way puzzle that you had to make sure it was available. It already had PennDOT approval, and you could work that into the design. So there was a lot of quote unquote borrowing from other contractors of PennDOT approved materials between the baskets and some of the precast elements.
Yeah. And Majid, you were able to turn a back-to-back MSC wall design around in 24 hours. Now, you mentioned that there was another similar project that had occurred recently, but what feat of engineering did you have to pull off to make this possible?
Sure. So Archie mentioned that. So when I Monday afternoon, I sent proposal to Archie, and internally we talked about it and said, yeah, this is emergency design, so we're not going to give them our typical 3 to 4 weeks. So I told Archie, we can finish this in like 2 weeks. Tuesday, I think it was around 5 in the afternoon, Archie called me and said, okay, good news, you got the design. I said, okay, perfect. And then he said, but they want it in 24 hours. So after freaking out for a few minutes, I talked to some people in the office. It was after 5, and then we formed a design team. I made some, because by that time everyone was almost out of office. I made some phone calls to the design members and said, okay, let's be in the office like tomorrow before 8 in the morning. So now it's Wednesday morning, we got together, we had the kickoff meeting, and we started the design at 8 in the morning. So for those who has designed MSC walls, in general, it's not a challenging design. It's not complex. So I'm not going to say the design was like super complex. No. It's just, as Archie mentioned, it's just a time. So we started working on design calculations and drafting simultaneously. Even for the design, I remember that at some points there were like 3 engineers working on different aspects of design. Like someone was designing the internal stability, someone else was looking at the global. Because of this a temporary wall that's supporting I-95, and there was like moment slab at the top of the wall, someone else was looking at how the loads from the moment slab going to transfer to the MSC wall. And because it's I-95, the lane's going to be a little bit narrower than normal. Potentially they're going to be accident. So we got to design this for impact force. And then every time something was done, we would give it to 2 engineers to check it. There was no room for mistake. So I remember working like nonstop for 17 hours. We finished everything Thursday, 1 in the morning. And I remember sending email to Archie. I sent him like both like calculation package and like construction drawings. So it was fun.
No, that's
very nice of you.
Yeah, that's fascinating. And I really like that you included the part about what you and your team did to make sure that the risk of making mistakes, given that fast pace, was minimized. And that's that's something that's a very good lesson for practitioners and students, that when the situation is unusual, that you can't skimp on making sure that things are being checked and checked twice. That's really neat. So Teresa, when you went through and described foam glass as a material, one additional thing that's like really interesting about foam glass, is that you can transport it in these large volumes, right? And this is kind of one of the big advantages of foam glass. You can I may get this wrong, but it's like in some cases like 90 plus cubic yards per truck. And so you're able to deliver these large volumes of foam glass to this project. It also happens that your plant where you are making this stuff is 25 miles about away from this event. So I'm wondering if you can just describe a little bit of the logistical operation of getting that material from the plant to the site. I know, it involves some pretty interesting cooperation with law enforcement and others to make that happen.
Yes, yes, absolutely. Yeah, so as you mentioned, right, foam glass aggregate is delivered in trucks that look very similar to like standard tractor trailers. We can get up to 100 cubic yards in a truckload, and very frequently we get up against weight limits for the truck before we reach volume limits. And so, we were only, a little over 20 miles away from the project site. We have a very good trucking partner that, we were able to call and put them on standby, and, stressed the importance of needing to get trucks on this so that we could really start delivering material even before the contractor needed it. So we were able to stockpile, the foam glass kind of up on top of the roadway adjacent to where the bridge had collapsed. So going from our plant up, you're able to hop on 95 about 2 miles from our plant. And the governor had actually asked the Pennsylvania State Police to provide escorts for all of our trucks. And so, each truck that left the facility had, a state trooper, kind of leading the way. And then, 95 was closed in both directions, obviously. So once you got past that closure, it was like, very open for the trucks to just go. But, again, with that trucking partner that we have, trucks were able to do multiple runs in a day. So they would, deliver a load and then turn back around and come back to our plant, load up again. And then they just were kind of doing loops all day long. So, the total amount of material that we supplied to this project was right around 8,000 cubic yards, give or take. So that is a lot of truckload deliveries, but we were able to do it with the partners that we had.
That's great. Yeah. So we're going to go to the chat and we're going to get some questions from the audience. So we've got a question from Nick Anderson, and he asks, is this product available on the West Coast? If so, what is the general cost range when compared to structural fill or aggregate base?
So it is available, and it's going to sound strange because we're talking about shipping aggregates, but we do dozens of projects on the West Coast. We've done some work at the San Francisco Port Authority. We've done work for Washington State DOT. We're doing some work in LA. And right now we're shipping all that from the East Coast. So we use intermodal, so we can use trains to get the material across country. However, we do have equipment on the West Coast in preparation for a plant that we're hoping to have opened sometime next year. So in the meantime, yeah, we're shipping. And to handle the price question, compared to traditional structural fill, depending on the area, Pennsylvania is a good example, we're more expensive than traditional aggregate. There's so many quarries here, right? You get to Florida, when you're looking at durable aggregates, we're a little bit closer. But the use of foam glass is not really replacing traditional aggregates. It's really looking at alternative lightweight materials and options for ground improvement more so than structural fill.
Yeah. I mean, there are increasing pressures in a lot of parts of the country because they're just not permitting quarries like they used to. So
yeah,
those economics may change. All right. So Robert Crawford asks, since the lightweight foam glass aggregate MSC portion was disassembled at the completion of its use, were any analytics done on the geosynthetics or lightweight foam glass aggregate components for wear or fatigue?
Yeah, that's a great question. Thanks, Bob. We did so first of all, this material that was removed from the temporary embankment is actually being reused on another PennDOT project just a little farther south on 95. So you can certainly reuse foam glass aggregate. We do generally say you might want to bump up the unit weight that you're going to use for design slightly, just to account for maybe some, additional, particle size changes that you might see from handling multiple times. So we exhumed some material. We did gradation analysis on that material, and it still fit within our gradation specification, which is that we allow 15% over 2.5 inches and 15% under 3/8 of an inch. And then we also know of folks that exhume some of the geosynthetics to do some testing on the geosynthetics. So the geosynthetic supplier is actually Husker Corporation. So they were able to get some samples. I think that they were working with the university down in North Carolina in order to do some testing. And then George Kerner at GSI was also able to collect some samples. And again, just, mostly comparing kind of the strengths after after it had been in service for that amount of time versus before it had ever been installed. So I believe that both Husker and GSI are publishing papers, if they haven't already, about this. And, I think they saw relatively positive results that, the amount of damage that they saw to the geosynthetic was relatively minimal. So all good news.
That's great. I do have to add that George Kerner was very nice to offer an internship to one of my students over winter break, and my student helped with the testing of the exhumed samples. And tremendous, chance in a lifetime opportunity to look at material taken from this unique fix. All right. So, this is a unique project, or this was a unique project, and as you were participating in it, like, how did you feel? It had to feel different than a typical project. I had a chance to get close to the site and see things, and it kind of instilled feelings of like patriotism. We were just we were doing this. It was getting done. So I wanted to know if do you have similar feelings, different feelings?
Yeah, I can tell you, like, when we got started, right, it was for sure a nonstop, really 24/7 type thing building up. And when we knew we were going to get started, building the wall was going to be on a Friday, but we were going to start supplying material on a Thursday. And the best example I gave you is I said, I'm going to get down to the plant way ahead of everybody. So I got down to the plant at like 4:30 in the morning, only to see, 10 news vans and 4 helicopters flying over the plant. So you're like, that's not every day at Aero, and the state troopers that took us up. But I can tell you, because the region knew about this and what was going on, when the first 4 trucks went up to deliver, I got in our company pickup truck to follow them up in the escort, and riding along 95, everybody in backed up traffic, because we were going down the left shoulder, were literally beeping and cheering the trucks on, because they knew they were heading to fix 95. So from that day right through the next 3 days, it was just nonstop on site, working with the contractor, with Majid. We had our plant people working round the clock to load. And it was just a pure adrenaline rush. 4 days worth.
Awesome. How about you, Majid? How did getting involved in this project, did it feel like not a normal experience?
Well, it was not normal at
17 hours of working. Yeah.
I mean, obviously, my participation in this project was not as involved as like Archie or Teresa. Like I said, we finished the design in less than 24 hours. So pretty much we were done. I mean, we got some comments the day after, but we were not involved like from day 1 to day 12. But for me, like everyone was working around the clock. There was like a sense of urgency, a sense of commitment. And knowing that we were not just trying to rebuild a bridge, but restoring a critical artery for the region. That was like incredibly rewarding for me. And this feeling, I think it gave me a deep sense of patriotism, basically. It was a unique project, yes, yeah.
And Mike, you know what? I'd add to that too, because I think, there were certain contractors that were hired by PennDOT to work, and Buckley definitely went all out on the project. But the amount of other contractors, no payment, not involved in engineers, suppliers, what can I do to help? How can I help? We had ACF, John Henry and his crew open up a plant after hours to get a roll of grid because we were short and drive it up in their own truck after hours. So right across the board, everybody involved and not involved, that was the feel. It was the best teamwork kind of, group process, like whatever it is we can do to help to get this done. It was all hands on deck. So it was really, really impressive that way, right across the board.
Yeah, astonishing. Yeah, I think Teresa is showing an aftermath celebratory event. This was thrown by Buckley, correct? This
No, this is actually showing the live stream that PennDOT. Yeah, so PennDOT, I think, did a really great thing where they communicated, everything that was happening on the construction site through a live stream that anybody could access, if you clicked on the URL from the PennDOT website. So what I was showing was a sports bar down by the stadiums here in Philly that, were showing that live cam and the stream. But, when I would sign on, there would be thousands of people also signed on to the live stream. And it really did, this project was really affecting most people in the region, right? Like even if you don't drive 95 each day, the traffic being pushed from 95 to the other roads in the area, it was probably affecting you there. So, again, it was just, that was a really great thing. It was a really intense, couple of weeks for us at Aero. Just, I don't know if Archie slept that whole time, but as Archie mentioned too, everybody was putting in those hours, right? PennDOT folks, contractors, and suppliers like us, and designers like Majid. So,
yeah. And a little detail, Mike, that probably didn't make the article was, the secretary of the DOT, Mike Carroll. He was relatively new, right? He was only put in the position this year. Day one, he showed up, and his comment was, "I'm not going home until 95's open." And my first thought was, he doesn't have a construction background. He could be here for a very long time, but true to his word, he stayed there every day and he worked from the site, watching what was going on, working out of his car. So, even from the highest levels at PennDOT, you saw that kind of commitment to get it done.
Yeah, it was really, really astonishing to see. What was also astonishing to see was a presidential briefing involving Archie. Do you want to talk a little bit about that whole event?
Yeah, not in the original business plan. I can tell you that, Mike, for sure. And so I was on site Friday night. The wall was coming up pretty good, and I got a call from the governor's office saying, "We'd like you to come to the airport to do a briefing in the morning with the president." And honestly, it took a half a second, president of what, until I realized they meant the president. And so went down early, had to do the Secret Service briefing, and went into a cleaned out airplane hangar with a presidential podium and a table with foam glass on it. And, for most of the engineers, and especially the geotechs on it, it's interesting when they say you need to give a briefing on lightweight fill and geotechnical engineering, and you have 15 minutes. Go. So you don't get to cover everything, but the biggest thing was the governor presented it as this new material, which was a double-edged sword. A lot of people thought this was the first time foam glass was ever being used. A lot of public thought we were stacking up broken bottles. They were worried about getting flat tires. But to go in and do that experience, to be vetted out to literally meet a sitting president and explain what you do with lightweight aggregates and how it was going to work was definitely a highlight of my career for sure. Little, pinch worthy, but it really was phenomenal.
Yes. Yeah. It didn't probably have that in your 2023 bingo card.
No, for sure.
Sweet. Before we wrap up, I've got just Bill Stevens missed the first part of our show here, and wanted to know the unit weight of foam glass. So Teresa mentioned it was bulk unit weight. It's about 15 pounds per cubic foot. Once you compact it, and there's a little bit of moisture involved, about 23, 24 pounds per cubic foot. All right. So before we wrap up, I just wanted to kind of touch base on like where things are now. And this is an event that was in some ways a little bit of a fork in the road a bit, with an opportunity that none of you saw coming. And it turned out the fix worked. The fix worked. They opened the embankment in 12 days, sent traffic on it for a couple months, and I drove on it a few times, and I'm waiting to feel that bump at the end of the road, and it was smooth sailing. So by all accounts, the fix was an astonishing success. And so I imagine that there's been some kind of after effects that have already occurred, and maybe some things that have yet to occur. So can you elaborate a little bit on some of the opportunities you think may have come about from this?
Yeah, so I would say from my perspective, one of the major things that came from this is just the increase in awareness for people about foam glass aggregate. As Archie mentioned, when Aero was started about 7 years ago, like nobody in the U.S. had heard of foam glass before. It was really starting from scratch. From that time, I like to think we've done a pretty good job, certainly with the geotechnical engineering community, kind of spreading the word. But after this project, I mean, you have, the general public knowing about foam glass, not to mention kind of the greater civil engineering community. So, that's always been one of the challenges as a new company with a new material, is just making sure that, folks realize that this can be an option, in their design process to utilize it. So
I would think too, Mike, to add to that, we know from day one with Aero and foam glass, it was really awareness. How do we get out? And Teresa does most of the heavy lifting for Aero on that. And we're not really a big marketing firm, right? It's a group of engineers, the whole company. So most of us it's writing technical papers, presenting, going to geotechnical conferences. So the awareness got raised because of this. But for the last year, mostly by invite, we've been invited to a lot of different state DOTs and ASCE meetings and GI meetings of, okay, we do want to learn more about this. So like Teresa said, we've got everybody from, the general public now that's aware of foam glass to Federal Highway telling us there's a jar of Aero aggregates in the west wing of the White House. So, we've kind of got quite broad awareness now since that. So that's something that we kind of say, if someone gave us $1 million for a marketing budget, we could not have spent it better than the exposure from that project.
How about you, Majid?
So for me, I can say like being part of this project, being part of this experience, both like personally and professionally, I feel like it reinforced my belief in the power of teamwork. I saw teamwork, the power of teamwork. There is a crisis, we can work together and accomplish great things. Also for me, being part of this experience, I feel like I'm more passionate about geotechnical engineering. I'm more passionate about everything I do every day. So now, I consider myself lucky to be part of this project. Sorry, Archie.
I know, and now all of Majid's clients know he only needs 24 hours to turn
Yeah.
designs around.
Unfortunately, yes.
I talked about a double-edged sword. Yeah. So we have another question. This is from Amir, and he is wondering, have there been any studies regarding seismic properties, lateral pressure coefficient, shear wave velocity, damping? Anything on that for foam glass?
So not yet, but there might be something in the works regarding that. A lot of the time for seismic design, if they're looking at embankments applying loads to structures, really the important thing that they need to know is kind of the unit weight of that fill. So that up to this point, that's really been the primary information, that and friction angle, right? But because we are planning to expand to the West Coast, and we do know that certainly the West Coast of the U.S. deals with these seismic issues a lot more than we do here on the East Coast. That is something that we're putting into our R&D budget for the next year.
Great. Well, this has been a fantastic conversation. I read the article. I was aware of what was going on as it was happening, but certainly this was a great conversation, and got to hear some new things. So thank you so much, Archie, Teresa, Majid, for taking time out of your day to talk about your article. If you haven't read the article, please do. It's worth your time. And this event, which you're seeing live, if you're hearing me talk at this moment, will be put on the Geo-Institute's YouTube channel. So you can revisit it at any time you want. You can share it with your colleagues, your students. I will be sharing this with my students at Lafayette College for sure. Teresa was gracious enough to give a presentation on this project back last fall, but this is a great supplement to that. If you can't get enough of foam glass aggregate, GeoStrata has more to offer you. This article is actually the third article on foam glass aggregate in the magazine. So other articles on foam glass are available in the September-October issue in 2018 and the October-November issue of 2022. So I encourage you to look at all three of these articles. And if you're unfamiliar with the material, maybe start all the way back at the 2018 article, because that kind of is more talking about the material as a material. And then this latest article is really a great case history of it in action. So I want to thank you all for spending some time with me this afternoon. And if you're not a member of the Geo-Institute, get on it, become a member, and I will see you all around.
Thanks, Mike.
Bye.
Mike.